Hey guys, I hope you all are doing great. And now we will be starting with the concepts of gravitation that we have left. So I think last time we have left at Kepler's law. Yeah. So we'll start with the Kepler's first law. I think I have already explained you. Second law I've explained you, and yeah, the third law is something that needs some logical understanding. So the third law goes like the square of its period of revolution around Sun is directly proportional to the cube of mean distance of a planet from the Sun. Now let's understand what it is saying. Square of period of revolution means what is the time period of a planet to revolve around the sun. It is denoted by capital T, right? And a square of period of revolution means square of T, that is T square, around the sun. This is my sun, is directly proportional means if this will increase, the other will also increase. Cube of mean distance of a planet from the sun. Now let's understand it one by one. Mean distance of a planet from the sun. What does this term means? That the distance of planet from sun actually varies. If you see this diagram, you will see that distance of a planet, if it is here, the planet is here, there will be some other distance. If the planet is here in this region, EF region, it will be having some other distance. So yeah, the distance is increasing or decreasing, but the mean distance, that is average of all this distance, we will find out, and we will realize that T square, that is square of period of revolution around the sun, is directly proportional to cube of mean distance of a planet from the sun. So T square is directly proportional to R cube. It means if you will increase the T, R will also increase. It means that T square by R cube is always constant, okay? Because if you increase the T, R is also increasing. So there must be some constant, and it is denoted by K. Now Kepler obtained this law simply from the study of positions of planets obtained by regular observation. He had no explanation as to why planets obey this law. We will see below how these laws help Newton in formulation of his theory of gravitation. So here comes the Newton universal law of gravitation, which is very important to understand. So all the above considerations, including Kepler's laws, led Newton to formulate his theory of universal gravity. According to this theory, very important line this is, every object in the universe attracts every other object. Like even if you are sitting on a chair, you are attracting the chair is attracting you. If you are using a table, you are attracting the table is attracting you. And now with some definite force, yeah, there is some amount of force. This force is directly proportional to the product of masses of two objects and is inversely proportional to the square of distance between them. Let's understand this. Directly proportional to product of masses of two objects means, like if they are having mass m1 and m2, their product will be m1 into m2. And force is directly proportional means, force, if the force will increase, m1 m2 will increase, or if m1 m2 will increase, force will increase. And inversely proportional to square means, if the square is d, let's say the distance between those two objects is d, and since this is inversely proportional, it means that if you will increase the force, the distance has to decrease, or if you decrease the force, the distance will increase. Okay, now let's understand. These are two objects. Let's say these are two objects, mass m1 and m2, and they are apart from each other with a distance d. Newton said that the force between these two objects is directly proportional to m1 m2. You can see here, and since this is d is inversely proportional, it is in denominator. Then this was the proportionality. So yeah, so he found out some constant g and called it g is the constant of proportionality, and named it as universal gravitational constant. Okay, the above law means that if the mass of the one object is doubled, the force between the two objects also doubles. How? If say if mass m1 becomes 2m1, so obviously the force of the value of force become twice, right? Also, if the distance is doubled, the force decreases by a factor of 4. Now, how is this? if you double the distance, it will become 2d whole square, right? So it will become 4d square. So the actual value of f is this, and if you double the value, it will become f by 4. Now, if two bodies are spherical, the distance of the force is always along the line joining the center of two bodies. Now, what could be the center of this spherical body? The center will be somewhere near the center of the sphere. So, it is saying that the force will be along this direction, along the direction where the center lies. Okay. Now, let's understand. In case when the bodies are not spherical or having irregular shape, then direction of force is along the line joining the center of masses, and d is taken to be the distance between the two center of masses. Let me explain you with the help of some diagram. Yeah. So draw and this into shape. Now, first of all, let us understand what is center of mass. So if I draw a circle, or let's assume that this is a disk, so the center of mass will lie somewhere in the center, this region, right? Now, if I have a cylinder, like I am having this shape and it is a cylinder, okay, this did not work well. Like, let's say if I'm having some cylinder, okay, disk will be having the center of mass in this region, and let us assume that if this is a sphere, the center of mass means the place where you can imagine all its mass. Okay, so yeah, let's go back to the concept and understand what it wants to say. Now, if F is equal to G, which is called universal gravitational constant, mass m1 and mass m2 divided by d square, so there is the thing that we can understand, right? Like, if the d will increase, if the denominator will increase, obviously the value of force will decrease, and if the mass, any of the mass will increase, the value of force will increase. Now if you see, it is d square, so if you divide, like if you half the distance between this, let's say these are two masses, m1 and m2, these are two masses m1 and m2, and yeah, this is the line joining their centers. So, and let's call it d. It says that if I reduce the distance by, like, if I halve the distance between them, the force will decrease 4 times. It is correct, because if the d becomes if the distance of these two objects become half, it will become d by 2, and d by 2 whole square of d by 2, right? This will become the distance, but the force is actually the square of the distance, like inversely proportional to square of distance. So it will become like this, and this will be equal to d square by 4, right? Okay, now let's go back to the topic. Yeah, so if you will see here, that this sentence, I hope you have understood now that if the distance is doubled, So distance will become d by 2. Okay, this example was actually a little bit, there is some mistake in this. If you decrease the distance, it will become d square by 4, and this 4 will go to the numerator, so the force will become 4 times. But if you, let's say, if you not decrease the distance, if you multiply the distance or increase the distance by multiplying it by 2, so the square of 2d whole square will be equal to so that will be equal to 4d square. It means in denominator we will be having 4, and that is why it is saying that if the distance is double, the force decreases by a factor of 4. Now from equation 2, from this equation F is equal to g m1 m2 by d square, it can be seen that value of g is the gravitational force acting between the two unit masses. Unit masses means two masses, and yeah, at a unit distance away from each other. What it wants to say is, if you put the value of mass as 1, m1 is equal to 1, m2 is equal to 1, and d is equal to 1, F will be equal to g, right? So the same sentence it is written here. The theory part is the value of g will be is the gravitational force that is equal to F between two unit masses. It means m1 and m2 have value 1 kept at unit distance. It means d's value is equal to 1. So thus in SI units, I hope you all are aware of SI units, the value of g is equal to the gravitational force between two masses of 1 kg kept at 1 meter apart. Now let's see, yeah, what about the center of mass? So center of mass is of an object is the point inside or outside the object at which the total mass of the object can be assumed to be concentrated. Now the center of mass of a spherical object having uniform density means they are not they are having same mass and same volume along the every corner. So it will have uniform density, and center of mass of any object having uniform density is at its centroid. So why did Newton assume inverse square law dependence on distance in his law of gravitation? He was helped by Kepler's third law. Now it will explain how Kepler's third law has helped Newton to formulate this equation for a gravitation force. So consider an object moving in a circle with constant speed, like it is just taking the example of a planet. We have seen earlier that such a motion is possible only when the object is constantly acted upon by a force directed towards the center of the circle. Like yeah, such a motion is possible only when the object is constantly, let me explain you this too. So let me take a new page. Yeah, what the author wants to say is, if you are having any two objects, okay, let's say these are two objects or these two planets, and if this if this planet is actually revolving around this, let's say this is sun, this is the sun, and if this planet is revolving around this axis, or if it is in a circular motion, that is because there is a force attracting this object, right? So it is what is this is written here, like we have seen earlier, that such a motion, circular motion, is only possible when the object is constantly acted upon by a force directed toward the center of the circle. Now this planet will exert, this sun will exert a force on this planet, attractive force, which is called gravitational force, which acts toward the center because this is at the center of this orbit. So that is why the circular motion happens. Now let's go back here. Yeah, the force is called centripetal force. I have explained you this in the lecture 2. So if m is the mass of the object, v is its speed, m is the mass of the object, v is the speed, and r is the radius of circle. So m is the mass of this object, okay, m is mass of this object, and with speed, the speed with which it is rotating is v, and this distance is r. It says that the force that is attracting towards the center of the object, let me choose some other color. Yeah, the force which is actually acting upon this object towards the center, right? Because this object is doing a circular motion. It is revolving around this star, so or the sun. So there is a force which is acting on this planet, and the force is around towards the center of the circle. Okay. So the value of that force, centripetal force, will be equal to mv square by r. Okay, this is the formula. You might not get it now, but you must remember that if an object is moving, in circular motion, the force acting upon it towards the center is mv square by r. Now v is the velocity or speed, r is the radius. If a planet is revolving around sun in a circular orbit in uniform circular motion, then the centripetal force acting on the planet towards the sun must be mv square by r, right? Because if the planet is revolving around the sun, if you read this sentence, it is not there, you will understand it. Now the planets are revolving in a circular orbit, right? And they are revolving in a uniform circular motion. What is uniform circular motion? It takes equal time to cover equal distance. So every 1 year we are getting, like we are having a new year every year, right? So why it is happening? Because the planets are revolving around the sun in a uniform circular motion. Then the centripetal force. What is the centripetal force? Centripetal force is the force that acts upon the object when the object is moving in a circular motion towards the center of the circle. Now, sun must be F is equal to mv square by r. So the author wants to say that even if the planet is revolving around the sun, there must be a force acting on the planet because the planet is revolving in a circular motion, and the force must be toward the center because the planet is revolving in a circular motion, and the value of that force will be mv square by r. Now let us understand it more clearly.
Okay guys, so now we will start learning about Newton's universal law of gravitation. So let's study in detail how Newton's universal law of gravitation works. So let's take two objects. Object can be a planet, or can be any tree, or can be human being too. But since we are talking about universal law of gravitation, we will take planet. So let's say we are having two planets, and mass of the first planet is m1, mass of the second planet is m2, and let's say the distance between these two planets, this distance is denoted by symbol d. So m1, m2 and d, these three are variables, a name given to any value. m1 is the mass of the first planet, m2 is the mass of the second planet, and d is the distance between them. So what Newton discovered was that force is directly proportional to m1, that is mass of the first object, into m2, that is the mass of the second object, divided by d square. So this was the formula that Newton invented or discovered, you can say anything. So basically it says this force is gravitational force. So you must understand what a gravitational force is. Gravitational force is the force acting between two objects in any universe, like at any distance of any mass. If there are two objects in the universe, they will be attracting each other with this force. This is not the accurate value of the force. So later on Newton discovered one constant. Constant is basically a number that we provide or update our formula so that we can be able to find the exact value of force. A constant value, like if you have any two objects in the universe, you can find the force existing between those two objects. But yeah, if you are using G as the constant, you must know that the force that you will find will be universal gravitational force. Okay, so I hope you guys understood what is universal gravitational force or Newton's law of gravitation. Now let us go to other topic, and we will learn the formula that is involved in uniform circular motion or magnitude of centripetal force. You will find this in the chapter first on page number 5.
So here we are talking about chapter first, page number 5. So this part, okay. So yeah, now I will explain this entire concept equation here and how this thing is derived. So please pay your attention.
So it is saying that to find, there is a basic formula that speed is equal to distance upon time, right? Now let's say if I give the symbol V for the speed, and let's say if I am having a planet, a tiny little planet who is revolving on this axis, okay, and let's say this axis is actually a circle and it has a radius r, okay. So we all know that the total distance that it will cover from here to come back to here will be 2 pi r, because 2 pi r is the perimeter of this circle. So yeah, so according to this formula, speed is equal to distance upon time, we can see that distance will be 2 pi r, and let's denote time by capital T. So we can see capital T here. Now when an object rotate or revolve around in a circular motion, you must have seen, I have also explained you in the Zoom meeting lecture 2, that there is a force that is applied to those objects, okay. This force acts towards the center of the
This force which we are talking about is centripetal force.
circle. That is why, because of that force only, that objects keep trying to come inside the circle. Let's say if you are rotating a stone which is tied to a string, okay, and let's say if I cut the string at this place, if it is rotating like this, and if I cut the string at this place, the stone will directly go in the straight direction.
Here I am taking the example of tangential direction, the tangential velocity.
Right? It means that every point, let me erase this. It means if this is the orbit and if this is the planet, every time the planet wants to go in this direction, but because of the circular force, or we can say because of the circular motion that it is doing, it has to come to the inner direction. About this point, let's talk about this point. So we can find out the tangential velocity. Velocity is nothing but speed, but we are also taking the direction, okay. So yeah, at this point if I draw a tangent, this will be my tangent. So let's say if I am having a string and a stone is connected here, if I cut the string at this place, the stone will travel directly, right? Yeah. So if I take the planet, if I take this planet, these two planets, let's say this is Sun and let's say this is Mercury. So I can say that these two planets are having some force, right? There must be some force because there is no string between Earth and Sun. There is no string between Venus and Sun. So there is a force that acts on that planet which makes the planet or pushes the planet to come or revolve in the circular motion rather than just going directly in the tangential direction. So that force is actually gravitational force. Yeah. The force existing between Sun and Mercury is the gravitational force, and that is why the Mercury has to keep rotating around and around and around of the Sun. Just like how you tie a string and try to rotate it, you tie a stone to the end of a string and try to revolve it, right? So it is performing a circular motion. So let's see what the circular motion, what will be this force. So there is a law for circular motion too. The law says that whenever an object is revolving in a circular motion, it applies some force. There is some force which is applied on it, and that force is equal to mv square by r. Very simple it is. M is the mass, v is the velocity, and r is the radius. Let's say if I am having a hand is here, and here is a tiny stone, and you are revolving this stone in the circular direction with the help of string. So the force, if you want to find, is very simple. The more force you will apply, the faster this string will revolve, right? Yeah. So the force, if you want to find out, it is very simple. Just put mass, what is the mass of this stone, multiply it by the speed, every time it is having some speed, and divide it by the radius. Okay? Great. So now, let's see why.
Now this radius what we are talking about is nothing but the distance of the object from the center of what it is revolving. Like if any object is having any circular motion, it will have a center, right? So the distance between the center and the object is nothing but this radius.
We are talking about it. So just before this, we tried to find out what will be velocity if velocity or speed if an object is rotating or revolving in an orbit. Okay, so it will be mv square by r. If I see my velocity, my speed, not velocity, because velocity also has direction, and when an object revolves around the sun, it changes its direction every time. So velocity is changing. Now let's go in detail. So this must be the speed, and this is also the force that is applied. Now if I want to find out the exact detail of force, or if I want to find out the value of constant, what can I do? Let's see. I will substitute here v. This v that I have, I will substitute here by 2 pi r by. So let me erase this. And for any object that is moving in a circular motion, the force is equal to, the speed, basically v. V will be equal to 2 pi r divided by t. Let's substitute this here.
This speed is equal to 2 pi r by t. 2 pi r is the distance covered, because if a circle is having radius r, the perimeter will be equal to 2 pi r. And the speed is equal to distance upon time. If the t is the time period and distance is 2 pi r, so obviously this equation of speed will be equal to 2 pi r by capital T.
See, that 2 pi r by t whole square will become 4 pi square r square divided by t square. So yeah, what we will find here is m 4 pi square r square divided by t square, and we are already having one r here, which we will put it here, right? Because the whole square of this term will be 4, 2 square will be 4, pi square will be pi square, and r square will be r square. I hope you all are familiar with pi, very strange number known as 22 by 6.
What we have done here is simply substituted the value of v square in this same equation by this. So if we have my v is equal to 2 pi r by t, I've just put v square here.
7. Yeah, the value is 22 by 7. So yeah, let's see what can we do. This r can divide this r, so we will have only one r at the top. So we are having one value which is equal to 4 m pi square r divided by t square. Okay. Now there is a third law given by Kepler. I hope you have heard of Kepler. I have told you what is Kepler's first and second law. So the third law of Kepler goes like t square by r cube is equal to k, where the k is a constant. I hope you all are familiar with constant. Constant means nothing but some value. It will have some integer value like 456 or 634. So yeah, So it is very simple meaning, like constant means just a number. So what we will try to do is we will try to simplify this equation and try to relate it with the Kepler's law. So I can see I am having r cube here, right? So I will do one thing, I will multiply this equation, I will multiply by r square and I will divide it by r square because the value will be same, right? Because I am multiplying and dividing with the same number. Now let's see, if I multiply r with r square, it will become r cube. And yeah, here we will have, in the denominator, we will have r square. Now, t square by r cube is equal to k. So, r cube, if you try to see this term is r cube by t square, right? So, t square by r cube is equal to k. It means 1 by k will be equal to r cube by t square, right?
What I have done to this equation is just multiplied r square to the numerator and denominator. So r square into r will become r cube, and if you multiply r square to the denominator, it will become simply r square. Now what we are going to do is we are using the Kepler's third law, which says that t square by r cube is equal to k. So 1 by k will be equal to r cube by t square, which we are getting here.
It means this is 1 by k. Now what can I do? I can substitute this value 4 and pi and divide it by k, right? Because it is r cube by t square. T square by r cube is equal to k. So if I multiply this number 1 by, or we can directly substitute it by k at denominator, I will have this 4 and pi by k.
Here there is a little mistake that it will be 4m pi square, but that is completely fine. I will tell you why.
And yeah, we will not be having r square in this case probably. Let me see the equation, r square k, right? Okay, yeah, this is what we are getting. Now there is one thing that you must understand. This 4 is a constant, right? This pi is a value which is constant. This k is also constant. This m, the mass, is also constant. So only one thing that is changing will be radius. If the object is moving in a circular motion, the only one thing which will be changing will be the radius.
What I am trying to say is that to change the force, we can only change the radius or the distance of the object, nothing else.
Okay. So yeah, we got it. Now let's see the solved examples on page number 6. Yeah, the example.
Okay, before moving to solved examples, I hope you have understood this part. And now Newton concluded that centripetal force, which is the force acting on the planet and is responsible for circular motion, must be inversely proportional to square of distance between the planet and sun. Inversely proportional like this, F is equal to 1 by r square, right? So Newton identified this force with the force of gravity and hence postulated the inverse square law of gravitation. So the gravitational force is much weaker than other forces in nature, but it controls the universe and decides its future. This is possible because of the huge masses of planets, stars, and other constituents of universe. Okay, you must remember this line: the gravitational force is much weaker than other forces in the nature. Okay, now we will talk about these examples. These are very basic and simple examples. If there is a, like Mahendra and Virat are sitting at a distance of 1 meter from each other, the masses are given, it is asking about the gravitational force. Here there is an important point to remember is that the value of G is given. G is called universal gravitational constant, that it means it will be fixed for any planet. Now let's go there back and understand this.
One is very simple. Mahendra and Virat are sitting at a distance of 1 meter from each other. Their masses are 75 kg and 80 kg. What is the gravitational force between them? So let's say this is Mahesh and this is Virat. And what are their masses? 75 kg is mass of Mahesh and 80 kg is the mass of Virat. Okay, cool, very easy. Now what is the distance between them? They have specified that 1 meter is the distance between them. They have also given the value of G, which is the universal constant, 6.67 into 10 to the power minus 11 Newton meter square divided by kg square. You should know the value of this constant, okay? Newton meter square by kg square is nothing.
No means you should remember this value in the exams, in the board exams. It might be possible that they will not give you the exact value. So at that time, you have to use this value on your own.
But the unit, everything has unit. So similarly, it has also a unit. So how will you find the force? Very simple. What was the formula of force given by Newton? G m1 m2 divided by r square. Put the value of G here. Let's say this will be the m1, this will be m2. Put the value of m1 and m2, and r will be the distance between them. So r will be 1. So put 1 here. Calculate the value, you will get the answer. Very simple, right? Now there will be cases when they will give the force, but
this is an important thing to understand, because if you will understand it, you will be able to solve other questions too. So pay attention what I am trying to say.
they might not give the mass 1. So what you will do, you will take the r square here, you will multiply force by r square, you will take the g here, it will come in denominator, you will divide it by g, and then you will divide this by m2. So you will get the mass 1. Like they will give, we are having 1, 2, 3, 4, 5 value here, right? 1 should be known to you, that is G. And what they will do, like these 4 values, they will always miss 1 value. And they will ask you to calculate that. So you have to simply calculate them by putting some arithmetic operation. So it is that simple. Now if you go on the page number 8, there is a topic which goes like Earth's gravitational acceleration. So what is acceleration? You might see, if you drop an object from some height, the object...
Okay, so I hope you have understood the questions. Like, okay, great. This we have understood. And if you take the second example, okay, so here they are saying that it is using v is equal to u plus at. That is very simple. Like there were 3 equations given by Newton. The first one is v is equal to u plus at. Now v is the final velocity, u is the initial velocity, a is the acceleration, and t is the time. So the question is, assuming that the bench on which Mahendra is sitting is frictionless. Frictionless means there is no friction. Starting with 0 velocity, it means initial velocity is 0. What will be Mahendra velocity of motion towards Virat after 1 second? It is very simple to understand it. So you know that initial velocity was 0. You know that we have time 1 second, and we want to find out velocity, the final velocity. So what we need, one more thing we need is acceleration, and acceleration force is equal to mass into acceleration. So acceleration is equal to force upon mass. We have already calculated the force. We have simply divided the force by the mass, and we got the acceleration. Now we have simply put this equation value of acceleration, and we have found out that the final velocity will be very small. Okay, this is an extremely small velocity. The velocity will increase with time because of the acceleration. The acceleration will also not remain constant, because as Mahendra moves towards Virat, the distance between them will decrease. And if distance will decrease, we know that the force is equal to gm1 m2 by r square. So force will also vary. Okay, simple. If you have any doubt, you can let me know in the classes when I will be taking them. Yeah, now let's talk about Earth's gravitational force. The Earth attracts every object near it towards itself because of the gravitational force. This is known to all of us, because that is why whenever we are throwing any object in the sky, it always comes back. The center of mass of the Earth is situated at its center. So the gravitational force on any object due to Earth is always directed toward the center of the Earth. And because of this force, an object falls vertically downwards on the Earth. Now let us understand this by the diagram. Okay, let me have a planet. Okay, yeah. Now let's say if I am sitting at this part, I am sitting somewhere here, and Yeah, I'm sitting somewhere here, and if I throw a stone in this direction, right, this will be my sky. If I throw a stone in this direction, the stone does not go here, right? It doesn't fall at any other place. It just comes straight back. It comes straight back because Earth is a sphere and the gravitational force acts toward the center of an object. Now, for any point, if you come at this point, let's say this point is A, if we talk about this point and let's say this point is B, if we come at this point and let's talk about this point is C. So if any object is here in this sky, the force that will be acting upon this object will be towards the center of the earth. That is why when you throw a stone in the sky of the like probably in the sky, it comes down straight downward. It doesn't go to the right or left, or if it is going, it might be because of the wind but not because of the gravitational force. So similarly, when we throw a stone vertically upward, this force tries to pull it down and reduces its velocity. So what happens is, like, let's say if I'm throwing a stone, if let's say if I'm on a ground, this is my ground, I'm standing here, okay, and I'm throwing a stone, I'm having a stone and I'm throwing it. Let me draw a stone at least. Yeah, this is stone. If I'm throwing, it goes starting first in the beginning at a good speed, and then the speed gets reduced, and after that at some point the speed becomes zero, and then it starts falling back and the speed start increasing. Why? Because when it was going up, Earth's gravitational force was trying to pull it down, and because of the Earth's gravitational force, this object stopped at one particular point, and then after it, what happened was that the object started coming back to the earth. So yeah, so this is again a question on gravitational force. Mass of given, radius is given, Mahin's mass is given, and what we have to do is just simply put the values. You can see g, m1, m2. You must remember the mass of earth because they will not tell it, so it is very important that you remember it. And yeah, okay, so now let us understand this. According to Newton's law of gravitation, every object attracts every other object. Thus, if the earth attracts an apple towards itself, the apple also attracts the earth towards itself with the same force. Yeah, this is correct. Then why then does the apple fall towards the earth, but the earth does not move towards the apple? Now, I will explain you this logic. Let us understand it in two different ways. Obviously, the force, like they have also given the explanation, the gravitational force due to Earth also acts on the moon, because of which it revolves around the Earth. It is correct. Similar situation exists for artificial satellites orbiting the Earth. The moon and artificial satellites orbit the Earth. Orbit means like they revolve around the Earth. The Earth attracts them towards itself, but unlike the falling apple, they do not fall on Earth. Why? This is because of the velocity of moon and satellites along their orbits. If this velocity was not there, they would have fallen on the Earth. Now, what the author wants to say is, if let's say if this is my Earth and this is my moon, okay, let me select a moon. Yeah. So this moon, why this moon is not falling on Earth, even if the gravitational force is existing between them? So the reason is because this moon is having some velocity, some speed, and that is why it is revolving in the circular motion, right? And because of this reason, the moon is not coming on the earth. But what about a stone? When a stone actually throws up, the speed becomes zero at a point, and after that point the stone falls back to the ground. So this is the reason. Now let's talk about apple and earth. So if I'm having an apple, it may be very small like this, right? And the size of earth will be very huge. So if earth will attract apple and apple will attract earth, who will win? Because the mass of earth is too high. So the movement, or if you try to find out acceleration is equal to force upon mass. Okay, yeah, okay, let me write m. Now if the mass is too high, what will happen? The value of acceleration will become too low, and if value of acceleration will become too low, so the equation that v is equal to u plus a t If this value is too low, the speed will also be low, right? This is speed v. So that is why it is not observable, the earth moving towards the apple, because the speed is too low and the force is also very low on the earth. Now let's understand this. The earth exerts gravitational force on objects near it. According to Newton's second law of motion, a force acting on a body results in its acceleration. Thus, the gravitational force due to earth on a body results in its acceleration. This is called acceleration due to gravity. Now, what is acceleration? You must understand this. To understand acceleration, let us take an example of magnet. Let's say I'm having two magnets. I hope you have seen magnets of this shape, right? And if you keep them at some distance apart, and initially if they are at rest, they will start coming towards each other, right? They will be attracted because of the magnetic force they have, and initially their speed will be less, very less. But once they come closer, if they come closer, you will see that their speed becomes too high. The increase in speed is called acceleration. The rate of change of speed, let me explain you through the given theory. So earth also has an acceleration. It is denoted by small g. Acceleration is a vector. What is a vector? A vector means something that has some value and also has direction. So acceleration has direction, right? As the gravitational force on any object due to the earth is directed towards the center of the earth, the direction of acceleration due to gravity is also attracted toward the center of the earth, that is vertically downward. Now what the author wants to explain is, like, if this is my earth, what is my force, like in which direction am I having the force? The force is along the center, right? So acceleration will also be along the center, that is vertically downward. That is what the author wants to explain. Now we will see how we will calculate the value of g on surface of earth.
After coming after coming a little down, the speed will increase eventually. The more it comes down, the higher speed it has, the faster it goes. The speed is increasing because of the force which is applied by earth. We are having our earth here, right? So that earth applies gravitational force on the object, and that is why the velocity changes. Now the rate of change of velocity, rate of change of velocity is denoted by symbol small g. Be very careful. I'm telling this once, I might not repeat that again.
At this point is very important point.
And you are going to make this mistake probably 10 times. This g is gravitation due to acceleration, but this g is universal gravitational constant. So this g will never change, but this g will change if you go on the different planet, because that different planet will have different mass. What we are trying to do now is we will try to find out acceleration for the earth, only for the earth. Yeah. So let us erase this. Now, let us talk about the equation part first. So F is equal to G, capital G. Mind this is capital G, universal gravitational constant which never changes. This is one mass, this is the other mass. You can write m1, m2 also, that is fine. Now, this is the force, this is the equation for force. So what we will try to do is, we know, like in simple terms, we know that the odd object, like if there is an object of mass m, tiny m, the force applied by earth on that object is equal to m into g, right? We all know this. But now we are trying to learn how this g, this small g, is derived. Okay, we will try to calculate the value of this z, because the very basic fundamental formula of force is equal to mass into acceleration. This is the most basic fundamental, like the very important formula, and from this formula we are deriving other formulas. Yeah. So you must know this. Now acceleration is nothing but the how fast the velocity or speed is changing. Now here our g, small g, I have denoted small g, I have just kept the name small variable g is assigned for Earth's Earth's gravitational acceleration. Okay, so the small g will be nothing but the acceleration for the object m which is on Earth. Okay, so this force is nothing but mass into acceleration, and this force is the force applied by Earth or applied by any object on a mass m. Now what we will try to do is we can see that this mass and this mass are equal. So we will try to find out what is the value, exact value of acceleration. So what we can do, we can equate these two equations. M and M will be cancelled. You will get G. Now this small g is equal to capital G value, which is 6.67 into 10 to the power minus 11, and there is some unit we are not using it, multiplied by mass m. This mass, since we are calculating for Earth, this mass will be the mass of the Earth. Now what is the mass of Earth? It is 6 into 10 to the power 24 kilogram, right? This is the mass of Earth. And what is the radius of Earth? We all know that the Earth is very large, right? So the radius would obviously be large. It is 6.4 into 10 to the power 6. But there is something missing, the square sign. So we'll put the square sign here. Now, if you will calculate this value comes near about 9.77, and if you will write the exact unit, you will find it will come near about 9.77 meter per second square. So you must know that unit for acceleration is meter per second square, and value of g for Earth will be 9.77. I will not repeat that again. This g is a small g. It varies from planet to planet. But this g is the constant. It is universal constant. It will never vary. So for Earth, the value of small g, that is gravitation, acceleration due to gravitational force, is 9.77 meter per second square. Now there is something that I want you to revise from class 9 probably. V is equal to U plus AT. S is equal to UT plus half AT square, and V square is equal to U square plus 2AS. For those of you who do not know about this formula, it is completely fine. I will explain it again. Now let us understand about these three very important formula which will always come up in your life to kill you, especially in the exams. So what are these three formulas? They are very simple if you will understand them once. V is the final velocity, U is the initial velocity, A is the acceleration, and T is the time. S is the distance covered, U is the initial velocity, T is the time, half is a constant, A is the acceleration, T is the time. V is the final velocity, U is the initial velocity, A is the acceleration, S is the distance covered. Now what will happen if we are talking only in the terms of Earth? So for Earth, the value of acceleration is g, right? So I will replace this A with g. This equation is correct. This equation is also correct, but for only small values of g. Now small values of g on Earth is 9.77. So it is completely fine if you are solving some question. Let's say there is a question where the user or the author is asking, like a person is standing at a height, say the height is 100 meter, and he has a stone in his hand, and he drops the stone. Now the drop means he is not throwing it, he is just dropping it. It means, very simple, that initial velocity was 0, right? Because he is just dropping it. So the question might be that you have to find out the final velocity. So it would be very simple. Since you know that u is equal to 0, you know that the height that stone will cover will be 100, and you have to find final velocity, and this equation does not include time in it, right? So this equation will be the perfect equation because this equation will ask for time. So you can simply include that u square will become 0 and 2 into 9.77 g, value of g on earth because it is dropping on earth is 9.77. So it will become 977. Why? Because it is 100 meter. So S is 100 meter. So it will become 977, which will be equal to 7 to 14. This much. Right? So this will be value of V square. Be careful. They are asking value of final velocity. Now final velocity is V, not V square. So you have to take a under root of this, and this will be your final velocity. Very simple, right? Now we will learn about escape velocity.
Okay, so I hope you understood this part too, where we have derived the value of small g. This small g is known as gravitation, acceleration due to gravitation, Earth's gravitational acceleration, and we have found the value as 9.77 meter per second square. Now let us see how the g, value of a small g, varies if you change along the surface of the earth. Like if will the value of g be the same everywhere on the surface of earth? The answer is no. The reason that the shape of earth is not exactly spherical, we all know this. So distance of a point on surface of earth from its center differs from somewhat from place to place. Yeah, it is right. Like if I'm having a sphere, wait, let me explain you this. So our earth is probably not of circular shape but of a little spherical shape, yeah, like this, right? And it is also a little bit tilted, yeah. Now what the author wants to say, that this distance that we have and this distance that we will have, these two are not equal, right? So basically r is varying. If r is varying, it means that g will also vary, because what was your formula for g? If you remember, it was equal to g, capital G, mass of the planet divided by r square. This formula is not derived by me. This formula is given here. They have derived it, right? G is equal to gm by r square. So if you go due to its rotation, the earth bulges at the equator and is flatter at the poles. Yeah, it is correct. This is the equator and this is probably the poles. These two are the poles. So yeah, let's go back, and it's flatter at the poles. Its radius is largest at the equator and smallest at the poles. Okay, my diagram is actually a little wrong. Let me explain you why. Probably the shape of earth would be little like, no, it is a perfect circle. Let me try again. It is again a perfect circle. Again a perfect circle. Again a perfect circle. Oh my god. Yeah, somewhat like this. Okay, yeah. So it is like yeah, if you see, this is the equator, this part, and these two are the poles. So if you are standing here, your value of r will be larger, right? So earth bulges at the equator. Yeah, earth is probably like this, not this much bulging, probably like an egg. Let me show you a diagram of an egg. Okay, yeah, somewhat like this, right? Somewhat like this. Yeah, so if we talk about this, our shape of earth is probably like this. And if you see, the distance of this egg is more at the equator. Like if I'm standing at this place, my distance from the center will be little larger. So that is why the radius is largest at equator and smallest at poles. So value of g is highest at poles. Why high? because we are dividing it by radius, right? So if the radius will be small, the value of g will be high. Now radius is smallest at poles. If radius is smallest at poles, it means g will be highest at poles. And if radius is largest at equator, it means the value of g will be smallest at equator. Now change with height. As we go above the height surface, the value of r in equation increases and value of g decreases. Yeah, it is correct. Because as we go up above the height, like if you go in the sky, our r will increase, right? Our distance will increase. So our gravitation due to acceleration will decrease. So change along the surface. On the surface, if we are on the surface, we can see the change in g. If we are going to some particular height, we can see the change in g. And whatever change in depth, obviously if we are going deep inside the earth, the value of g also changes. If we go inside the earth, the value of r in equation 5 decreases, and one would think that the value of g should increase as per the formula. Now if I tell you like how I have explained you must be thinking, if we go inside the earth, if we go inside the earth, probably at this place, our distance from center is decreasing. It means that r is decreasing. It means that g should increase, but you should be very careful. In this case, the g is not decreasing. What the other ones should say is, uh, the part of the earth which contributes towards the gravitational force felt by the object also decreases. Now let's say if I am at this point, at some particular this point, okay, now what will happen? Now there, this part of earth is not exerting any force on me, right? If I am here, I'm avoiding this external part of earth which can exert a force on me if I'm standing outside. If I'm inside, the complete earth will not be exerting force on me, so the value of mass will decrease. So uh, which means the value of m to be used in equation 5 also decreases as a result of change in r and m. So basically if you are inside the earth, your r is changed, it is confirmed, but m is also changing because you are inside the earth, the mass is distributed, right? And because of the combined effect, the value of g decreases as we go deep inside the earth. So you must remember this. And now every planet and satellite has different mass and radius. According to equation 6, the value of g on their surfaces are different. You should remember this. On the moon, the gravitational force is 1 by 6th of the value of earth. As a result, using the same amount of force, we can jump 6 times higher on the moon because the acceleration is low. If the acceleration is low, it means that the force that the moon will apply on us or any object will be low. Okay, now let us understand the difference between mass and weight. I hope you know this, but mass is the amount of matter present in an object. SI unit of mass is kg. Mass is a scalar quantity. A scalar quantity means it does not have any direction. Its value is same everywhere. Okay, its value does not change even when we go to other planet. According to Newton's first law, it is the measure of inertia of an object. Higher the mass, higher is the inertia. Now what about weight? Weight of an object is defined as a force with which the earth attracts the object. The force of an object of mass m on surface of earth can be written as weight is equal to force is equal to mg, where g value is gm by r square. Now if you are on earth, you will simply put the value of g as 9.77, but if you are on moon, the value of g will be little low, and if the value of g will be low, value of force exerted on you will be low, and hence if you will weight yourself on moon, you will feel that your weight is too low, or the weighing machine will give a low value. Now weight being a force, SI unit of weight is Newton. Also it is a force, so it is a vector because force has a direction, right? And direction is toward the center of the earth for the gravitational force. Value of J is not same everywhere, we have learned that. And weight of an object changes from place to place, but its mass is constant. Weight changes from place to place. Why that happens? Because weight is equal to mass into G. Now this small g varies on different planet. Even on the earth, if you are, the small g varies, but that is not the case with the mass. Okay. Now, okay, I think there is one last sum they have, and we have free fall. Okay, yeah, we will cover this topic probably in next lecture. This much is enough for now. So yeah guys, if you are having any doubt, please let me know. You can send me on WhatsApp or you can comment it here. but probably send me on WhatsApp, or I will take the class in the next week. So you can obviously, like this coming week, we will be having our own classes, probably every day. So be prepared for the doubts and be prepared very well. Thank you so much, guys. Bye. Take care.